All right, so good morning. Last week we've been looking at a lot of long division of polynomials. This week we're going to be looking at synthetic division. Now this is sort of like a shortcut when dividing polynomials, but you can only use this shortcut whenever you are dividing polynomials by binomials. Now what I mean by binomials is I'm talking about things like this. So our divisor needs to have in x a variable that has the exponent of 1 and the coefficient 1 and a constant. So you can't use something that looks like this or like this x squared minus 1 or this x to the cube plus x plus 1. Neither of those are going to work because they don't have the coefficient of 1 and the exponent of 1, and they don't have that coefficient right next to it. Now, the way this is going to work, the way I'm going to set up actually, is I'm going to just use the coefficients and the constants of the polynomials I see here. So for example, outside where our divisor goes, instead of writing x minus 3, I'm just going to take the opposite of the constant right over here. So the constant is negative 3. I'm just going to put a positive 3. So I'm going to leave that as a positive 3. Now the dividend, I'm going to take the coefficients, but if you notice here, we have x cubed, x squared, and then we're missing that x. Because we're missing that x, it's going to be like the last time. I'm just going to put a 0. Now let's just set up what's inside. So the coefficient of x to the third is negative 1. The coefficient of x squared is 4. The coefficient of x is 0. And the coefficient, well, there's no coefficient. The constant here is 9. So I'm just using their coefficients and the constants, no variables. Now, the way this is going to work is that I'm going to bring down, and then I'm going to multiply. So here, I'm going to be multiplying 3 times negative 1, which we know it's going to give you a negative 3. Now the difference here, instead of subtracting, I'm actually going to add next. So I'm going to add these two. So I'm going to be doing, let's see, 4 plus negative 3, and that's just going to give me a negative 1. So that's what I'm going to have down here. Actually, it's not going to give me a negative 1. It's going to give me a positive 1. So that's what I'm going to put down here. And then this cycle is going to start again. I'm going to multiply. So I'm multiplying 3 times 1, the one I got from here. And you're going to get 3 again. Going to put that right under the 0. And then you're going to go ahead and you're going to add. So here you're going to be doing 0 plus 3, which just gives you 3. Oops. And then you're going to start with multiplication. So here, now that I have the 3 down here, I'm going to multiply this 3 with this, the divisor, and then I'm going to get 9. And then from here, I'm going to add. So 9 plus 9, this gives you 18. So here, the numbers I have down here, notice how instead of writing my answer on top, I'm actually writing in the bottom. These represent the coefficients of the answer of our quotient. So what's going to happen here is whenever we have to know that whenever we divide, usually the leading degree is going to be one less than the degree of your dividend. So this is x to the third power, negative x to the third power. I'm going to put, for my answer, I'm going to put x, negative x, because this is a negative 1, to the second, right? These represent the coefficients of our answer. Now I'm going to move on to this 1 right over here. It's a positive 1. So I'm going to write positive x, because right after 2, we go to, right before 2, we go to 1. And now we know that once we pass the x variable, the plain x variable, we're going to go to a constant, which is going to be 3. And then over here, this, since we can't go below our constant, this will represent our remainder. And the remainder we're going to write the same way from our long division problems. We're going to have the 18 as the numerator, and then we're going to have our divisor, x minus 3, as our denominator. So this will be the answer using synthetic division. So if you notice, this is a small amount. This is shorter compared to long division, but you have to remember that you can only use this method when your divisor looks like this over here, when it's a binomial. All right? Okay, so that was synthetic division.